Outstanding. Well, thank you, Glenn. I do appreciate that. Bless your heart, Glenn. Bless your heart. I love that shirt, by the way, Code Blooded. I should ask you where you get some of those shirts because you definitely have an outstanding collection of them. So thank you, sir. And I'm quite certain I'll sprinkle It Depends in here somewhere, don't you think? I feel pretty strongly about that. How about you, Jakub?
I'm pretty sure you will, my friend. I'm pretty sure.
All right. All right. Outstanding. Well, let's dive in and see what kind of trouble we can get ourselves into. We spring is a large topic, which I think should be fairly obvious if you've been hanging around with us today. And Jakub and I have been playing this software game for a while, and it used to be simpler. We had a monolith or two, and we released periodically, and we all worked near one another, whether that was on the same floor, or at least within walking distance. But that's just not the world we live in today. In fact, there's a pretty good chance that you've got dozens or hundreds or thousands, or we're not even sure how many services. And if I asked you when was the last time that a new version dropped, you'd be like, I don't know, earlier today sounds about right. And of course, your team isn't all in one place anymore. I mean, Jakub and I are separated by 7 hours in our wonderful time zones. And so this job has never been easy. And now we've got these massively distributed applications with these geographically dispersed teams, and we've got to try to make that all work. Now, I remember when I was a young, naive developer, I thought, boy, it must be great being an architect. You just sit around all day, drinking espresso. Sounds like a good gig. And then I became an architect and realized, wow, there's just not enough of us to go around. We're spread really thin, and we can't, in fact, be in all places at all times. We can't be involved with every decision. We don't want to be involved with every decision. We must empower our teams to make good decisions when we're not there. And the way I like to think about this is essentially distributed decision making. Now, my job as an architect in many situations is to establish principles, to take advantage of the power of defaults. The power of defaults is an amazingly useful thing, and it actually has changed the way many people invest for their retirement. When I first started in the real world, you had to enroll actively in your 401k plan. And most companies have flipped that bit to you need to actively unenroll after your first day on the job. And the idea here is that people just tend to kind of go along with the way things are, and they don't tend to sort of disrupt the waters, as it were. And unsurprisingly, this dramatically increased the number of people who are enrolled in a 401k plan. This is really the underlying aspects of behavioral economics. And this concept was powerful enough that it earned its creator a Nobel Prize. And the way I would sum it up in a very short amount of time for us as software folks is, if you want to get somebody to do something, make it easy. That sure seems obvious, but it's good enough to get yourself a Nobel Prize if you think about it in terms of economics. Maybe Jakub and I need to figure out how to do that for software, although I don't think there is a Nobel Prize for software. As an architect, I can use this to my advantage. And I know this may be a little strange. Why am I talking about economics? As architects, we can actually wield the power of defaults as well. And we can make the right choice, the easy choice. If you've been in this space for any amount of time, you realize very quickly that these distributed systems all have very similar needs. We have to have observability and monitoring. We have to be able to see what's going on in this system. We need circuit breakers to deal with the inevitable things when something breaks. We need consumer-driven contracts, gateways, streams, externalized configuration. How do we do functions, service discovery, load balancing, documentation? There's all these things that appear on projects over and over and over again. I can't have every project roll their own, reinvent the wheel here. This is what makes suburban sprawl look lovely. What I appreciate about Spring is it frees us to focus on these critical design decisions while empowering our teams to solve critical business problems, because that's what we need our teams to do. Our customers want us to put code into production reliably and repeatably, and I need to be able to do that knowing that my teams are not going around inventing their own thing every time they come up with a novel problem. There's a lot of ways to fail with distributed applications. What I love about Spring is it's here to help you, help your teams, help your application, help everybody get a better night's sleep. At the end of the day, this is all about delivering business value to production. Now, let's start by just saying, what is spring? I think for most of the planet, it's a season. It's generally a very lovely season, although maybe the fall's nicer because it's not quite as wet. Ultimately, it's an integration framework. And the idea here is to combine together a lot of different things, very consistent programming model. It grew out of a very strong desire to simplify Java development. I am old enough to have done J2EE, let alone JEE. And EJB's had a lot of extra overhead that came along for the party. And so Spring came along and said, hey, we can do this in a way that's simpler. It doesn't have to be this hard. Now, over the years, it has grown considerably. It supports Kotlin, it supports Groovy, and it is ultimately this family of projects built atop the Spring framework. What I think is so amazing about Spring and the Spring team is they have managed to evolve and provide support for basically every application architecture that's in play today. It sort of grew up in that traditional servlet-driven web app concept, but it certainly is not limited by that. If you're doing message-driven applications, no problem. Traditional web app, fine. Reactive, no big deal. Microservices, we got you covered. What I love about Spring is it gives us choices, and it doesn't paint us into corners. This is something that comes up a lot in software. I know things are going to change. I don't want to be stuck in a situation where this change is going to be crippling. I need to anticipate what some of that is, while in the same vein, walking this thin line, but I don't want to get into Yagni land where I'm building a bunch of stuff that I'm not going to need, and I do all this effort for something that never happens. Spring gives us a lot of flexibility, abstracts away a number of things. If you need to switch your message broker at some point, no problem. Your application's just writing to and reading from, and you can go ahead and swap that out. Want to try a different data store? Again, no worries. You can go ahead and make that change with fairly minimal coding updates. The team does amazing work to stay backwards compatible and to work with older versions of Java and not just break when something changes. It does cover a range of JDK versions. They go out of their way to minimize breaking changes, certainly within a release. Obviously, major releases, things do and will change. The APIs are really thoughtfully designed. I mean, this is really developer UX, in my opinion. These are user-centered APIs, and it's really, really high-quality code. I was teaching a software engineering fundamentals last night, and one of the recommendations I made was you should go read more code, and Spring is an excellent example if you're in the Java ecosystem. Very well-written code, very clean code with outstanding documentation. Now, Spring's been around a while. First release was back in 2003, and I know in software speak, this is like Paleolithic era to some people. I think that's the wrong way to look at it. This thread's one of my all-time favorites, talking about, developers have this sense that old things are always arcane and complex, while the new is simple and elegant. In reality, though, the new is unfinished, buggy, and unproven, whereas the old is stable, refined, and tested. And so we shouldn't kick something to the curb just because, well, it's been around for a while. Again, one of the things I appreciate so much about Spring is it has grown and evolved as software has grown and evolved. And I think that's really remarkable. As I mentioned earlier, the goal here was to simplify JEE development, so kind of give us the promise of EJB without the pain of EJBs. And so it was built around this POJO concept, plain old Java objects, and then took heavy advantage of inversion of control, otherwise known as dependency injection. So this gives us that loose coupling. It is a very declarative programming model. And in fact, once you kind of understand that pattern, it applies very consistently throughout the entire framework. And so kind of learn once, use many places. Eliminates boilerplate. I am not a big fan of boilerplate, to say the least. Even if my IDE or a tool can generate it for me, I still have to drag it along and read it and modify it. And not a fan of that. Now, it has grown considerably. You look at something like Spring Boot, there's an awful lot of stuff sitting underneath that. I'm a big fan of Spring Boot. I wrote an application this spring to scratch a personal itch and give me an opportunity to explore some of the new things. What I love about Boot is it gives us this very opinionated view of Spring and making it much simpler for us to build an app. Now, it is not an application server itself, although it does embed a servlet container. It's not there to implement the Java specs, but it'll configure beans that do. Now, some people look at it and say, oh, it's magic or it's a code generator. It's not. It's there to automatically configure these beans for you and free you up from a lot of that boilerplate that we've had to deal with in the past. It all starts with Spring Initializer, start.spring.io. What I love about this is you go in and you say, what do I need for my project? You can pick all the things you want, and you can actually look and see what is the configuration for this. I've actually done that before. It's something Glenn taught me about, that you can actually see what this is going to look like. So if you're not quite sure what the configuration is on an existing project, you can just ask Spring Initializer for that. So you pick your language, you pick your build preferences, boot version, etc., set your metadata, whatever your packaging style is, Java level, and away you go. And you can go in and select what other dependencies you need. All right. And so you can just type in, I'm going to need a database, or I want to do reactive, or I want to do, REST, etc. And you just go ahead and type that in, and bam, bam, bam. And it goes ahead and gives you a starter project. Some customers actually will take that and sort of modify it a little bit to say, this is our sort of standard starter set. This is what we want people to start with. And now I've got a project that's ready to rock and roll. Now, if you don't like GUIs, it's fine. You can do it from the command line editor. Most IDEs have this baked in as well. You take that artifact, open it up in your favorite IDE, and you've got a project that's ready to start. Spring Cloud is where an awful lot of my world lives these days. These distributed applications have a lot of similar patterns. And so Spring Cloud gives us this large umbrella project with a bunch of out-of-the-box solutions for common things in the cloud space. Lot of stuff here, to say the least. These are defaults for cloud native applications. We don't care what cloud you run on. It's all good. Go to the same starter page and you can go ahead and configure the bits that you need. It externalizes configuration. There's a lot of integration with some of the components that have come out of Netflix. So you think of things like distributed tracing, the event-driven bits, distributed security, pipelines, connectors, service discovery. We'll go into this in a little bit of depth here before we're done here today. And then, of course, there's Spring Data, which thank goodness for Spring Data, because I learned early in my career that I'm not that good at doing SQL. I did just enough SQL that they wouldn't let me do SQL anymore. And so thank goodness for Spring Data, because it gives me this Spring model for data access. If there's a database out there, pretty good chance we can talk to it in some way, shape, or form. And so the beauty of this is it gives us this abstraction layer over that data store, whether that's a relational database, a non-relational database, one of the cloud-based options, MapReduce, time series, et cetera, lots and lots and lots of stuff there. And it gives me a simple way to talk to data. Now, at this point, I'm going to go ahead and stop my sharing. I'm going to let Jakub take a crack at this. He's going to show us this. Find my mouse pointer here. And remember where the stop share button is. Must be right here.
All right, thank you. Yeah, so as Nate mentioned, some of the applications, I would like to say, like most of our applications, they have some sort of database. They are stateful. I know there are some applications which are stateless, like functions, but typically most of us develop applications which have data. And also most typically, the data paradigm down there is probably relational or document-based or graph, something like that. And Spring Data JPA, part of the larger Spring Data family, makes it super easy to implement, for instance, JPA-based repositories if you happen to choose relational DB, or document-based repositories if you happen to pick like MongoDB, or graph-based repositories if you happen to pick, for instance, Neo4j, right? It makes it simpler to build Spring-powered applications that use various data access technologies. As you can see, in my application, I have two different dependencies. One of them says, hey, I would like Spring Boot Starter Data JPA. So it actually says that I will be query a relational DB. I will be storing and fetching data from some sort of relational DB using Java Persistent API, some sort of a provider like Hibernate or maybe Eclipse Link. All right, but then I need to add a second hint to my Spring Boot application. I would like to know, as the Spring application, which database, what actual driver you are going to use. And as you can see, the second dependency is H2 database. So thanks to those two dependencies, Spring Data will be able to auto-configure a bin, a data source bin that connects to an in-memory H2 database that will be easy to query and fetch data. Yeah, so now let's say I would like to query, I would like to store and then fetch simple credit card data structure. I want to emphasize it, data structure, not an object. I could do that with an object, but for the sake of simplifying this demo, we just have a credit card with two different fields that will be mapped to two different columns in a table called credit card in the database. So if I want credit card with some sort of data stored in the database, I need to use the annotation entity. You might be familiar with that. If I want to use an ORM, JPA-based ORM like Hibernate, for instance, probably I need an empty constructor. That's what the specification requires. So let's add some data to my credit card. Like for instance, probably I need ID. I want the ID to be auto-generated. So thanks to those two annotations, I'm able first and foremost to say, hey, this is a primary key. I use long, and please auto-generate whenever I'm storing a new instance of credit card to my database. And let's add something more. Maybe not string number, but like balance. Of course, I can add more, but let me simplify this demonstration, because very soon we are going to query and first store 2 instances or 3 instances of credit card, and we are going to see how easy it is to query by, for instance, balance. To make it easier, I'll just have a new constructor that takes balance as a parameter, maybe with long, and then we'll be mapping longs to big decimals like this. New big decimal from balance. All right, cool. So far, so good. So now, this is where Spring Data JPA really shines, because I can do this. The only thing that I need to do in order for me to be able to store and then fetch credit card records from, or credit card entities from the database, is to extend an interface. For instance, JPA repo, or if I want a simpler one, it will be a create, read, update, so-called CRUD repository. And then it takes the entity itself of the first parameter of this generic, and the second one would be the type of used ID. In our case, it's credit card and long. And now I can do this. For instance, maybe I would like to query by a specific balance less than an arbitrary chosen number. Yeah, thank you, GitHub Copilot. That's pretty helpful. Yeah, I can run this. Find by balance greater than. How it works is that the Spring Data knows that credit card has a field called balance, and thanks to those declarative queries, declarative method signatures, it's able to translate this to something like select from credit cards where balance greater than X, right? And of course, it's very, very, very verbose, not verbose, but powerful. I can do greater than X, less than X, between. I can play with timestamps, and I really encourage you to take a look at the documentation. It's really powerful, and it's really well documented what I can do with a simple method signature in an interface like this. To prove that it works, let's create a test. So we'll have credit card repo test. And in order for me to get the in-memory instance of H2, I'm running entire context of Spring Boot, but easily I could have done it differently, like just bootstrap the data layer with add data JPA test, but let's leave it like this. In the given section, we'll just create 2 different cards, credit card, yeah, 1 equals new credit card, balance 100, let's say. And then a second one would be, for instance, I don't know, 200 or 1. It's going to be easier. Okay. Then I will just store them in the database. In order for me to be able to do that, I need to auto-wire the credit card repo. So now I can save 1, right? Thank you. I can save the second one as well. And then I can query. I can use the method I want to say implemented, but we didn't implement it. We just declared that method like 2 minutes ago. Yes, thank you. Find by balance greater than 10. So it should give me 1 card. I can also use some other methods which are visible, which are present in the interface by default, like find all, find 1, find by ID, and so on. Let me find all, and let me fetch it to a different collection like this. And then I'm expecting something, right? For instance, I can assert that credit cards. So the first collection here has size of 1, right? It should be 1 because we'll be fetching just this. Of course, if we don't have any bugs in here. And the second one should be assert that all has size of 2, right? Find my balance greater than 10. Yeah, let me run the application, not the application, but the test itself. And if it's green, we are going to finish the demo. Yes, it is green. As you can see, it was super easy to implement and JPA-based repo. It's also super easy to test the repo and use the methods we provided. Again, you can do that with different paradigm, like with document-based application, with graph application as well. Spring Data JPA is a part of a larger data family. All right, with that, Nate, you can continue.
Outstanding. Well, and thank goodness for, again, that particular project, because I just don't know how to do databases. And so if it weren't for Spring, my application wouldn't be able to have a database. So that works out really great. Now, that does bring up the question, though, is what data store should you use on your project? And of course, Glenn, the only answer is it depends. Now, we could go on and on and on and on about this. I mean, there's full talks on just this topic. Glenn, in fact, has delivered one of them. What is Spring? You know, it's amazing how I forget that some people didn't grow up with this framework like I did or Jakub did or Glenn did. And so you come out of school today and you probably didn't learn this in college. There are excellent books out there as well on this topic, and there's lots and lots and lots of stuff out on the O'Reilly platform. If you're in this space, Jakub and I've taught there as well. We've written a lot about this. Unsurprisingly, as one could guess. Now, let's dive into Spring Cloud a little bit. Let's talk about fault tolerance. I know this is something that Jakub tried to get into this morning and had some technical difficulties, so we're hopefully going to rectify that here for you now. But one of the things you learn really early on is these distributed systems are not, in fact, islands unto themselves. A distributed system inevitably involves services that will fail. To paraphrase my favorite fictional chaos mathematician, failures find a way. Now, that's really inconvenient for us because our customers don't care why the application's down. They don't care whose fault it is. It's just, it becomes our problem. And one of the things you learn very early on in these distributed application land is you can't actually prevent all bad things from happening, but you can be prepared for it. You know, it's that SRE motto of hope for the best, prepare for the worst. Now, that does lead to a really interesting question, like, how should we react? Should we display an error message? Sorry, try again later. Should we call a backup service? Should I have a cached answer? Should I just return 42? Now, I learned a long time ago in software, there's 3 answers that work for every single question you get. The first one is 42. That's the geek check to see who's well read. As an architect, my favorite pattern is another layer of indirection. But the answer I have to give more often than not, and Glenn knows what's coming next, it depends. Now, when it comes to a distributed system, I really have to have a circuit breaker in play for any vulnerable call. And we often think of this as something that is a network call. It often is, but it doesn't have to be. It's any call that we're concerned about, anything that if this goes south, we're in trouble. Now, this originally was described by Michael Nygaard. And the basic gist is it works just like the circuit breaker in your house. If you plug too much stuff into a circuit, the circuit snaps open so that electricity can't flow through anymore and you don't burn out the circuit. I actually learned the hard way in my house that if we have both an air fryer and a microwave on the same circuit and you're using both at the same time, yeah, my house doesn't like that. And so pop, open goes the circuit. Now, unlike the circuit breaker in our house, though, software circuit breaker is a little smarter in that it can actually watch the calls and we can have kind of this intermediate state if we need to. And then, all right, everything's failing. Let's open up the circuit. Looks like things are back to normal. We're going to close the circuit again, complete the circuit, allow the call to finish through. And so basically that circuit breaker just sits there, watches the calls. Once we've exceeded some failure threshold, the circuit is open. There's no point in us continuing to call something that's not working. And then we can go ahead and redirect to whatever our fallback mechanism happens to be. And again, that's configurable and can be pretty much anything you can imagine. Periodically, it'll go to see, hey, are we back to normal? Or is this service repaired now? Cool, we'll close the circuit and go back to the way things were. Now, there's a bunch of different circuit breaker implementations Luckily, Spring Circuit comes along and gives us an abstraction over the top of that we can then use. And if teams need to switch out that underlying implementation detail later, they can. So we've got a nice consistent API. Developers can choose the implementation that works best for them. And we've got lots and lots of different options here. Now, Jakub will go through this here in a second, but the basic gist is we add the proper starter to our class path. We call the factory, and we now have this circuit breaker that we can inject wherever we need it in the code base. Again, any call that's vulnerable to this. You can configure each circuit breaker individually if you want. You can create a default circuit breaker that you can then pass around. It gives you an awful lot of knobs that you can tweak depending on your needs, from failure threshold, slow call threshold, how many calls, before something blows out, what's my window size, etc. So with that, I'll go ahead and turn it over to Jakub, and he'll actually demonstrate this for us.
All right. Thank you. So as Nate mentioned, there are different implementations of circuit breaker pattern, all of them abstracted thanks to circuit breaker in Spring. So for this demonstration, I have chosen, I don't think I will be lying if I say the most popular, at least when it comes to my observations, the most popular implementation of a circuit breaker pattern in Java world, which is Resilience for J. So if I want to use Resilience for J, what I need to do is I need to add the dependency, Spring Cloud Starter Circuit Breaker, which is the abstraction, and then the specific implementation, which, as we mentioned, is Resilience for J. All right. So I have a short, very short, get mapping /evaluate. We are going to evaluate clients, evaluate risk. If we can grant them, I don't know, a loan or a credit card or whatever. I think the application is running on my port 8080. So if I do curl localhost 8080, I should see okay, that's fine. But then let's do something more sophisticated maybe. Let's say we are delegating this call to a third-party service that we don't develop, we don't release, we don't maintain, but we have to rely on. All right, that's a third-party service. Let's say this service exposes an HTTP-based API as well. We are calling this service, and I'm going to simulate that HTTP call in here, like this. I'll have a failing risk client. It's going to be a Spring service, Spring bin, and it will have only one method called evaluate. So first and foremost, I will try to simulate that we are waiting, let's say, 300 milliseconds. So this is a simulation of a blocking call done via HTTP, okay? We are waiting for 300 milliseconds. I have to do this. This is just a demonstration, all right? Don't do that on production. This is just a demonstration. This is an HTTP call. And then, even though I have waited, for instance, 300 milliseconds, let's imagine this. I have waited 300 milliseconds, and then the service says, I'm not available. So I can simulate that with an exception, right? If I do new random dot next boolean, half of the calls will be unsuccessful. If I do this, only a quarter of the calls will be successful, and every 3 out of 4 calls will be not successful. All right, and at the end I will return manual or something like that. That's the evaluation results. So one more time, we are blocking, waiting for the HTTP connection to happen, and then all of a sudden, in most cases, we are getting an error. All right, let me connect our fresh failing risk client in here, failing risk client, like this, and let us delegate from this method to our failing risk client, and let us rerun the application and see what's going on right now. I will repeat the curl localhost 8080/evaluate as soon as it starts. It's up, so it should be working. Let me clear everything. All right. Okay, an error, an error, an error, manual, error, manual. So it's kind of working, but let me do something more, I would say, similar to what's happening in our production environment. With a tool called AB, I'm going to demonstrate 100 or simulate 100 calls to this API, okay? a localhost 8080/evaluate ab-n 100 calls to this API. So now what we are doing, we are hitting this endpoint 100 times, which means we are hitting this code 100 times, which means we are hitting this code 100 times, which means we are hitting this code 100 times. What that means in turns is that this benchmark will take at least half a minute, right? Because each of the calls lasts 300 milliseconds times 100. If my math skills are fine, that should take more or less 300, half a minute. And as you can see, time taken for the test, almost half a minute, right? We have 77 failures, so more or less 3/4. That's fine. And all of the clients had to wait at least 307 milliseconds, and the longest request took 314. So what's happening in here, if you have more and more and more, and all of them are blocked, we are not only saturating the connection between us and the application that we are calling. In this case, that's the risk management system, so to say. We are also not utilizing our resources well, and we are also making our clients mad because they will have to wait. They will probably click refresh, which means they will have to wait more and more and more and more, only to see an exception. So as Nate mentioned, in the circuit breaker pattern, we can kind of notice that if 10,000 calls in past 5 minutes were not successful, what's the likelihood of the next call to be successful? It's rather low, right? So maybe I will just return an error without having to call the external system, without you waiting for this amount of time, and without using the resources. That's actually more user-friendly. And circuit breaker pattern can automate that, and we are going to do that right now. So as you could see, I have the resilience for J on the class path. Now what I can do is this. I can inject circuit breaker factory in here. So this, this code that I'm going to write right now, what's going on here? Yeah, it's better. I'm doing that in the constructor just because I don't want to jump between files. It's going to be easier for the demonstration. Of course, on production, this configuration of a circuit breaker factory doesn't belong in here, of course. But in order for us to be able to see everything on one screen, I'm going to configure the circuit breaker factory in here. So how to do that? Nate mentioned a couple of parameters or a couple of states that circuit breaker can be in. For instance, if we happen to see 5 failures, we'll go to open state, and then we will wait 300 milliseconds. And if we wait 300 milliseconds, we'll allow 2 calls in half open state to see if maybe the API that we rely on is up again. All right, and then I can also add some default time limiter configuration. And finally, what I can do is I can add, I can add the configuration which is built thanks to those 2 smaller configurations. As you can see, I'm just providing default configuration for resilience for J with those 2 parameters that we just implemented seconds ago. All right, this gives me ability to do this. I can have a field in my class. I will call it evaluation, for instance. And yeah, this creates me an instance of a circuit breaker factory, not time, but this. Not time, but this, yes. And I will create that field right now. Circuit breaker evaluation, okay. And finally, I am able to wrap any call that I don't trust, any code, to be more precise, that I don't trust, because it doesn't necessarily have to be a call over the wire. It can be any code that we don't trust in a circuit breaker pattern. Like this, I'm wrapping this code that I don't trust, and then I'm providing a default response to, or try again maybe, or something like that. When I happen to see an error, I can do this, which means I will have no failures, because any failure will be translated to this response. Okay, enough of talking. Let me rerun the application and see what happens now if I do the same benchmark. If I do the same benchmark, I'll do I will do clear first and then repeat that benchmark. And I hope to see that the benchmark took less than 1 second. It means that only a few of the calls were actually hitting this, so to say, API, this external service. Almost, not almost, but exactly 98% were not hitting that because the circuit breaker was in the open state. By the way, at least for me, open and close is a bit counterintuitive, because when the circuit is closed, that means the communication can actually happen, everything is fine. When it's open, it doesn't work. All right. So the downside of that is the following stuff. Some of the calls that might have been successful, weren't even tried. Right? I haven't even tried to call the service. It might have worked. Maybe there was a likelihood, but I didn't care, to be fair. Most probably, it's a more user-friendly strategy to choose. As you can see, I have 0 failures. All of the requests were completed, but it's significantly faster. I'm not using the network just to see an error. I'm not using my threads. I'm not blocking my threads just to see an error. The client will repeat the call maybe soon, or maybe not. But I'm not going to wait for an error. All right. With that, I think we are done with circuit breaker pattern. We still have some time for monitoring, right, Nate?
I think so. Yeah, I agree with you. The closed always to me implies that, oh yeah, it must not be working. But I think of it as like complete. That tends to help the way I think about it. But your mileage may vary. And I do want to stress again, it's any vulnerable call. It doesn't have to be a network hop. So let's talk about observability. Observability had some pretty significant upgrades with Spring Boot 3, and it is vital that you have an observability story with a distributed application. Right? It is impossible to reason about these systems without that. And so this is really ultimately about collecting data about your system, and it involves a number of different topics: metrics, logging, tracing, etc. Now there's 4 kind of primary components to monitoring. There's logging. What is your service actually doing? We want to log anything that's useful as long as it's not personally identifiable information. Please don't ever put PII data in your logs. There are things that aren't PII on their own, but as soon as you combine them with other things, guess what? You got PII. Tracing can be difficult because I can't just put a breakpoint in and step through the code like I could before. Calls are going to bounce around, so correlation IDs are your friend. Speaking of which, Spring Cloud Sleuth to the rescue. Now, I know that there are some interesting things here. This is basically moved over to Micrometer, and so that's really the way that this happens to be working now. So that transition is occurring. There's a lot of good information here in that space. A lot of stuff here for you to use to be able to see into your system. And this is all auto-configured for distributed tracing. So it covers spans, key value pairs, gives you ingress, egress points. It will instrument those common ingress and egress points, and then give you Zipkin compatible traces if desired. So all you got to do is add that to your class path, and away we go. And now your boot can generate the trace data. We need some dashboards. So this gives us this view of health into our service. We want this to be displayed in some place that a person can view, but I want alerts when things really start to get out of band. Alerting is another key piece of this equation. So something isn't what I expected it to be. The goal here is to shift this left so that we can see the problem before our customers even notice. Now, luckily for us, some of this is actually baked in as well when it comes to things like actuator. We got to be careful with pager duty, by the way. We want to make sure people have good, clear, concise information. We don't actually rise to the level of our expectations. We fall to the level of our training. So we need to think about what we need to be monitoring. What's a key metric for us? Some things that we care about pertain to the infrastructure that this service is running on, things that have to do with the compute itself. That's probably going to impact more than just us. But then there's some things that matter to us, so these are things like availability, latency, et cetera. Pretty much anything we identified as an SLO. We do need to monitor errors. We do need to monitor exceptions. And one of the things I always challenge my grad students on when they're thinking about this is what's normal, what's warning, what's critical. This can be hard to figure out early on. We need a little bit of history. And I would argue this isn't just a prod thing. We should be thinking about this in staging as well. We want to validate those monitors and then again have that displayed in some place that a human can glance at to see how things are going. And then again, we alert when something goes out of band, because I don't want people just staring at dashboards all day. That's not a good use of their time. We want to alert on any key metrics. Absence of a key metric is an alertable offense. By the way, alerts need to be actionable, need to have a sense of urgency, and need to involve a human to intervene. If the system can fix itself, that's not an alert. That's a monitor and report later kind of thing. There's an awful lot going on here. This is where the SRE book comes into play. This is where we start talking about things like the 4 golden signals, things like latency, traffic level, error rate, saturation, etc. We do have to think a little bit about sampling frequency. High resolution is often very costly. So in many cases, it's in our best interest to aggregate data. And we got a lot of tools here. We've also got Actuator. Actuator is very powerful, and I think we maybe just have enough time for Jakub to demonstrate this. So let me go ahead and hide that.
Yeah, hopefully. I have, 4 minutes? All right, challenge accepted. So, as my friend mentioned, Actuator is the tool to pick if you want to have some sort of metrics, if you want to have observability. Yeah, so the only thing that you need to do if you want like basic support is to add the dependency Spring Boot Starter to Spring Boot Starter Actuator, as you can see in here. I think my application is running, so only thanks to this, you will be able to see some sort of information exposed by default, like default base URL is /actuator, and then I can see, for instance, the loggers which we have registered, as you can see. By the way, this is not only read-only, but with HTTP post, I am able to change an effective level, for instance, for this logger. We are not going to do that since we don't have much time. What else? Maybe beans. Oops, not mbeans, but beans which are registered. I can see some mappings, HTTP mappings. I can see, I think, scheduled task. We don't have any, that's why it's empty. I can see a thread dump, which I'm not going to do because you will see a sensitive information from my computer. I can expose some environmental data. Again, we are not going to do that from the same reason. I can do more and more things. All of that is documented in the Spring documentation, so I encourage you to take a look. If there is something you would like to expose and it's not there, you are able to write your own custom endpoint, and I think we have time for this. I'm not going to implement that, just uncomment, and that's pretty lame endpoint. It just returns a random number. Since we don't have much time, that's the that's the easiest stuff that we will be able to implement in 100 seconds. All right, so this endpoint will be exposed via HTTP. There is also an option to expose it via JMX, like this, or via both. That would be this. This will be the URL, so it will be /actuator/random. So now, if I run the application, you will be able to see, hopefully, actuator/random. If I don't have any mistakes, all right. Actuator/random. All right, we can see random numbers, not very useful information, but the system works. What else? You might be thinking, hey, exposing environmental data, thread dumps, loggers, anything like this without protection. Yes, you are right, but Spring Actuator integrates pretty well with security, with Spring Security, but for the sake of I wanted to simplify this presentation, and I disabled that deliberately. Don't do that on production, but as you can see, security is not enabled, is disabled, and I have half a minute to show the new API from Spring Boot 3.0. I think there was a presentation about this, so maybe it will be just a quick reminder. Now the API for observability is unified, so both for metrics and for distributed tracing, I will use the same sort of an API. Let's say I have this credit card controller which exposes one get mapping /card/number, and I want to observe that. So one way of observing that would be to use an annotation. I'm not going to do that. As you can see from micrometer, the annotation comes from micrometer. I'm going to use more declarative API, which is this. I can do observation, not observation view, but observation, create not started, and the name of the metric that we are going to observe, and then I'm passing the observation registry, so the registry to which we are sending the information. And then, oops, I need this. Observe, and I need to pass the supplier, which was this, without the return. All right. So far, so good, hopefully. Okay. Let me run this application. It runs on a different port, hopefully 8081. So there should be no collision. Let's see. Port, yes, 8081. And now, if I go to 8081 /card/ some arbitrary number, I'm getting something. And also, if I go to actuator /metrics, I am able to see that in the metrics registry there is card get metric, which we just created. I can hit that and see what's going on. The endpoint was hit 2 times. That's total time and some sort of statistics and also tags. All right, we are 2 minutes past the time, so I failed with the challenge, but I hope that's fine. Thank you.
Thank you.